Listening section directions. This test measures your ability to understand conversations and lectures in English. The listening section is divided into 2 separate timed parts. You will hear each conversation or lecture only one time. After each conversation or lecture, you will answer some questions on it. The questions typically ask about the main idea and supporting details. Some questions ask about a speaker's purpose or attitude. Answer the questions based on what is stated or implied by the speakers. You may take notes while you listen. You may use your notes to help you answer the questions. Notes will not be scored. In some questions, you will see this icon. This means that you will hear, but not see. Part of the question. Some of the questions have special directions. These directions appear in a gray box on the screen. Most questions are worth 1 point. If a question is worth more than 1 point, it will have special directions that indicate how many points you can receive. You must answer each question. After you answer, click on Next, then click on OK to confirm your answer and go on to the next question. After you click on OK, you cannot return to previous questions. In an actual test or during this practice test, a clock at the top of the screen will show you how much time is remaining. The clock will not count down while you are listening. The clock will count down only while you are answering questions. Click on Continue at any time to dismiss these directions.
Listen to a conversation between a student and a professor.
Hi, Eric. How are things going?
Oh, I'm really busy with my workload. Some professors assign so much reading that it's like they think we have no other homework.
One of the most important things to learn in college is how to manage your time. How to, prioritize. When to say no to a social engagement if you have a paper due, that sort of thing.
I guess so.
So, how are you finding the material we're covering in class?
I've actually come to talk to you about it. I have a 6-month-old niece, so I find early childhood development really interesting. Piaget, that Swiss psychologist you told us about, his development theory is really cool.
Yes. His theory that cognitive development in children occurs in 4 stages that you can actually observe.
Yeah, so my niece, she's in the sensory motor stage now, right at the part where she thinks things disappear when they're out of sight.
Very good. She probably won't understand that objects continue to exist even when they're out of sight until she's a month or so older.
Yeah. Yesterday, we were knocking a little ball around and it rolled under the couch. She immediately lost interest and reached for something else.
Because to her, the ball ceased to exist.
Yeah. I've actually been taking notes on her behavior because I'd like to write my term paper about her, if it's okay with you.
Your term paper?
Yeah. I'd like to do a case study or something. Piaget watched his kids and, changed the whole world of psychology.
Wait a minute. Piaget didn't just observe his own children. He did exhaustive research over 30 years to develop and test his theory. And anyway, your assignment isn't to do a study. It's to research the literature on a particular psychological topic and write about it. And I gave you a list of suggested topics to choose from.
Well, what if I research something like, is it possible to speed up cognitive development? Like, if I reached under the couch to get the ball while she watched me, would she learn earlier that objects don't disappear? Or can't 6-month-old babies think that way yet?
I do applaud your initiative, Eric. However, I sincerely doubt you could get any kind of valid or meaningful information from such an experiment.
But I already put so much time into watching my niece.
Remember, this is only a freshman psychology class. You aren't trained in carrying out an original research project. I wish you'd come to me earlier, but, there's still some time before the due date. I suggest that you recheck the list of topics. At least one of them relates to cognitive development. Then come see me again if you have any questions.
Okay.
The student visits the professor. Why does he go? Why does the student mention a specific early childhood development stage? Why does the professor talk about Piaget's methodology? Why does the professor not accept the student's suggestion to write a paper about his niece?
Disappear?
Listen again to part of the conversation, then answer the question.
Would she learn earlier that objects don't disappear? Or can't 6-month-old babies think that way yet?
I do applaud your initiative, Eric.
Why does the professor say this?
I do applaud your initiative, Eric.
Listen to part of a lecture in a theater history class. The class is discussing 18th century plays in Europe and the United States.
By far, the most popular genre of plays during the 18th century was the sentimental comedy. Now, in order to sort of get our heads around what a sentimental comedy is, where it came from, and why on earth it was so popular, we need to understand what sentimentality was as a philosophical movement. So, during the 18th century, some thinkers, philosophers, political theorists, came up with this idea of sentimentality. The main point in sentimentality is that people are inherently good. People are good by nature. In the past, in other times, some people had believed or claimed that men and women are naturally selfish or naturally evil. During the 17th century, there was a very popular theory known as the social contract, set out by thinkers like Thomas Hobbes, which argued that people are naturally selfish. During the 18th century, on the other hand, thinkers associated with sentimentality came along and said, no, people are naturally good. Yes, Diane, question.
Yeah, sorry to interrupt, but why was it called, that first one, the social contract? Why was it called that? I mean, if people are supposed to be naturally selfish, isn't that the opposite of being social?
The emphasis was more on the contract part. If people are naturally inclined to do what's in their own self-interest, then in order to have people living together in peace, you needed to develop some kind of a social contract, a sort of agreement. I won't hit you over the head and take your stuff if you don't hit me over the head and take my stuff. But in the 18th century, the sentimental theorists came along and said that people are naturally good.
Hard to believe sometimes if you watch the evening news.
Okay, If you try to argue that people are naturally good, you're going to have to answer the question, what about the fact that bad things happen? How do we account for the fact that people do bad things? Sentimental theorists claim that evil deeds happen because people are led astray by bad influences. That is, people can be pressured or seduced or tricked into doing something wrong. And the other question that comes up in relation to sentimentality is, if you are led astray, how can you be redeemed? Can you be brought back to your state of natural goodness? What do you think?
I think, yeah, if you think people are basically good, then you probably also think they can be, brought back to being good again.
That's right. And they said you do this by appealing to a person's natural instincts, trying to return them or connect them to their natural state, especially via the emotions. Making someone cry, then, could make them good again. Picture, for example, the evil villain smirking at his latest robbery and theft, who happens to see a lost child walking down the streets sobbing, and he starts to sniffle and cry, and maybe his heart goes out to this lost child, and he wants to help the child, and somehow he realizes that he's been bad, or rather been behaving badly, since according to sentimentalist theory, he was never truly bad to begin with. All right, that's sort of the hallmark of sentimentality, and it's what became the driving force behind sentimental comedies.
I don't get why they're comedies. They don't sound funny.
Well, you're right. A sentimental comedy is not specifically funny. The goal isn't to make the audience laugh. In fact, the goal's to make the audience cry. Thus, a sentimental comedy will usually depict someone virtuous, but in some sort of distress. Perhaps a good, virtuous man or woman who's suffering financial hardships, and we see them desperate for food, barely able to survive, tempted to rob someone. But they resist that temptation and still triumph in the end. And again, seeing this, the audience is expected to cry, and thus reconnect with their natural emotional state.
What is the main topic of the lecture? Select 2 answers. Why does the professor discuss social contract theory? Regarding sentimental theory, what 2 questions did the professor think sentimental theorists needed to solve? In the professor's opinion, what is the typical topic of a sentimental comedy? What is the professor suggesting is the primary goal of sentimental comedies?
For home.
Listen again to part of the lecture, then answer the question.
I think so. I mean, we talked about using the sun and the stars as navigational guides, and that would certainly be helpful for homing. And so would that ability to sense Earth's magnetic poles, the one in the studies you described about the internal magnetic compass birds have. Yeah, it should be the same.
What does the professor imply when he says this?
Now, in order to sort of get our heads around what a sentimental comedy is, where it came from, and why on earth it was so popular, we need to understand what sentimentality was as a philosophical movement.
Listen to part of a lecture in an astronomy class.
Traditionally, astronomers worked out how old geologic features of planets and moons are by the number of marks on the surface. The more craters in one place, say on a lava flow, the more asteroids and comets that place has encountered over time, so the older it must be. This seems to make sense for relative age. That is, a surface feature with fewer craters is younger than one with more craters. But absolute age, actual age, is trickier. We have to know exactly how old one surface is. For example, we do have a very clear idea of the ages of some surfaces of the moon from rocks we brought back. And then this information can allow us to extrapolate the age of another surface that has a similar concentration of craters. That's the traditional way to calculate it. But two developments have brought this traditional way into question. For one, a recent study of the craters on one of Jupiter's moons, Europa, suggests that at least 95% of its small craters were formed by secondary impacts. Okay, secondary impacts. They're the impacts of the chunks of rock or ice that break off as a result of the primary impact. The primary impact refers to the impactor itself, asteroid, comet, hitting the planet or moon. And when that happens, pieces of rock or ice break off and go flying, and when those chunks come back down and smash into the planet, those are the secondary impacts. So, using the old way, we would have assumed that this surface of Europa is much older than it might actually be. And it's conceivable that a very large strike from an impactor might throw up some fairly large chunks, ones that are larger than some of the smaller direct strikes. So we can't use size to determine if a crater is the result of a primary impact or a secondary one. And of course, impactors come in different sizes, though actually we think there are fewer small ones than there used to be. What really tells us more, though, is the arrangement, the way the craters are clustered together or not. For example, on Venus, the craters are distributed randomly. They're all over the place, which is what we'd expect. This suggests that there hasn't been much geologic activity lately on Venus, lava or whatever. But on Europa, the craters are in clusters. And since asteroids come from all directions, if the craters are arranged in bunches, it's a signal, especially if they're arranged in long ray patterns from a center point, that there was a single primary impact that threw fragments outward from the impact site. Another thing, primary impactors hit a lot harder and usually more directly than secondary ones. So primary craters tend to be deeper, more bowl-shaped, and almost always circular, which isn't the case with secondaries. Anyway, now let's assume Europa is representative of the inner solar system. That would mean there are a lot more secondaries on Mars or on Earth's moon or other bodies than we had originally thought. And here's some more proof. we got our hands on some nice photos of one particular crater on Mars, Zunil. And it turns out that this one impact caused many more secondary craters than we had thought. I mean, like 90 million more. So, if the impact causing each large primary crater, and Zunil isn't even that big, results in this many secondaries, then most of the craters on Mars must be secondary. And that makes sense, actually, since if all the craters, especially the small ones, if all of them are primary craters, well, there simply wouldn't have been enough small objects out there in space to account for all of those craters. And unfortunately, this means most craters probably aren't at all useful for dating surfaces on Mars. So, for example, some lava flows on Mars, which have been dated at about 5 million years old, very young, because of the relatively few craters there, well, it might only mean that this area was one of the random areas that wasn't hit by a primary impactor. It just makes it less clear. This lava flow could be 100 million years old instead. In this case, we can't predict the age with any accuracy unless we have actual samples from the planets. You know, we're getting great information and photos from our space probes all the time, but they also remind us of just how much more we need to learn.
What is the main topic of the lecture? Why did the professor mention rocks from the moon of Earth? What are secondary impacts, in the professor's opinion? In the professor's opinion, what factors do scientists take into consideration when trying to determine between primary and secondary impacts? Based on findings made at the Zunil crater, which ones does the professor suggest are more common than previously believed? Considering information obtained from space probes, what is the professor pointing at?
Listen to a conversation between a student and a librarian.
Hi, can I help you?
I hope so.
Okay.
I need to find an article in a journal called Contemporary Research in Linguistics, and I've looked all over the stacks for it, but I can't find it anywhere. Could you look to see if it's been checked out?
Okay, that may not be the problem.
But I just checked the computer catalog over there, and it's listed there, and it says it's available.
When you looked up the book locator number, did you see the letters LAN?
Oh, okay, yeah, I saw that, but I didn't know what it meant.
Well, that means it's in the language department library. We don't have it here.
Oh.
Yes, the university actually has 9 libraries, so you always have to check the library code when you're looking for a book.
Oh, okay. But it is available, but not in this library?
Right. But we do have a number of other linguistics journals here.
No, I need this one specifically. This article's mentioned in a bunch of other articles I've already read, and I wanted to have a look at the original. This one. You know, in case there's more stuff I could use in my paper.
Okay. Well, all the university libraries share their resources, so if you like, I could call the language department library and ask them to send it over, and we'd have it for you here, day after tomorrow around noon.
Oh, I appreciate that, but I can't wait that long. I need this article for a paper I'm writing that's due the day after tomorrow. Could you tell me where the language department library is?
Sure. It's on the other campus in the basement of Pearson Hall, across from the listening lab. But I doubt you'll be able to make it over there in time today.
No, especially since I don't have a car. But my sister does, and I'm pretty sure she'd let me borrow it. If I go over there first thing tomorrow morning, will I be able to check it out right away?
I don't see why not. Just make sure you have your student ID with you.
Okay, that's what I'll do then. Thank you very much.
Sure.
What is the purpose of the man's visit to the librarian? What does the man learn about the computer library catalog? How can the librarian help the man? Why does the man need to talk to his sister?
What does the librarian imply when she says this?
Sure. It's on the other campus in the basement of Pearson Hall, across from the listening lab. But I doubt you'll be able to make it over there in time today.
Listen to part of a lecture in a biology class.
Okay, I'd like to get started, please. Today we're going to look at some very unusual plants and animals that have evolved on some remote ocean islands. And of course, when I say that, the first thing that probably comes to mind is...
the Galapagos Islands.
Right, the Galapagos Islands, which are located...
in the Pacific Ocean off the coast of South America.
That's right, about 600 miles off the coast. And being so isolated from the mainland, the species that developed there were quite different from those that developed on the mainland. And of course, after Charles Darwin observed all of this, it got his wheels turning, and he eventually came up with his famous theory of natural selection. And that's why you've all heard of the Galapagos Islands. But we're not going to talk about the Galapagos Islands today. No. Way out in the middle of the Indian Ocean, somewhere between Africa and India, there's another little cluster of islands. Not nearly as famous, but every bit as fascinating in my opinion. A little group of islands called the Seychelles. Now, how many have heard of them? Okay, a few of you then. Well, it just so happens that I spent some time in the Seychelles a few years ago. So they're kind of close to my heart. And just like in the Galapagos Islands, an amazing variety of unusual species have evolved there. Things you won't find anywhere else in the world. For example, one of the things I saw there was a tiny frog that's not a whole lot bigger than an ant. In fact, it's one of the smallest vertebrates on Earth. Okay, here's a little mystery for you. You rarely get frogs colonizing remote ocean islands like the Seychelles. You have some other animals that an ocean current could carry out there from the mainland, but frogs are too delicate. They couldn't withstand the salt and the sun and so on for that length of time. So, how do you think the ancestors of these little frogs got there? Ken?
People brought them?
Good guess. People have been responsible for transporting a lot of species from one place to another.
Oh, maybe there used to be some kind of land bridge that used to connect the islands to the mainland? You know, like the one that used to connect Asia and North America?
That's close, Ken. Actually, the theory is, millions and millions of years ago, the Earth had only two huge land masses, two supercontinents. And then, around 200 million years ago, part of one of these land masses broke away and began to move slowly out into the ocean. And as that chunk moved away, fragments of it also broke off and were left behind. And that's how the Seychelles formed. And, so the theory goes, many of the plants and animals living on these islands were stranded out there in the middle of the ocean and isolated from the mainland. These tiny frogs are just one of the species descended from those stranded species. Diane?
I'm just curious, how did they figure out that the Seychelles were once part of one big continent?
Okay, that's a fair question. Well, there are two ways that I know of. First, you have some species in the Seychelles whose closest relatives are in Asia, and then you have others there that have distant relatives in both Asia and Africa. Now, of course, various species of animals and plants can drift or fly from island to island, so that in itself doesn't prove anything. And then I'm not a geologist, so I don't know all the details. But I do know that part of how they came to that conclusion was because the Seychelles are made up of solid granite bedrock. Granite is a type of rock that's typical of continents. Islands are typically made of volcanic rock. So if an island's made of granite, that suggests that it once was part of a continent. In fact, the Seychelles are the only islands in the middle of an ocean made of solid granite. The Galapagos Islands, the Hawaiian Islands, they're products of underwater volcanoes. Their composition's very different from that of the Seychelles. Okay, where was I? Okay. Okay, so then you had a relatively small number of plants and animals isolated for a long time out in the middle of the ocean, maybe with a few newcomers drifting in now and then. And so you got some very interesting things evolving. And speaking of that, I just happened to have with me a few hundred slides I took when I was there. No, just kidding.
But I do have a few slides of some things you've probably never seen before. All right, would someone get the lights, please?
Which aspect of the American West is the focus of the lecture? What was the main focus of Turner's presentation about the American frontier? When the professor talks about the theories of Turner and the new Western historians, what does she emphasize? Which of the following statements about Turner is most likely to be accepted by new Western historians? Mention if each statement represents the new Western historians or Turner's view of the American West.
Listen again to part of the lecture, then answer the question.
So, how do you think the ancestors of these little frogs got there? Ken?
People brought them?
Good guess. People have been responsible for transporting a lot of species from one place to another.
What does the professor imply when she says this?
Good guess. People have been responsible for transporting a lot of species from one place to another.